Hello everybody and welcome back to Business Statistics Online at Frederick Community College. In this video, I will show you how to use Excel for hypothesis testing problems. So if you would like to follow this video along, go to Blackboard and go to Module 3, Week 12, and in the Graded Assignment folder, there is a file all the way on the bottom that will let you do all of the computations needed for hypothesis testing relatively quickly. So this is the file that we will be using. It should look like this. You might have slightly different numbers, but that's okay. So this video assumes that you are familiar with the definitions associated with hypothesis testing. You've done your reading, you're comfortable with notation, and now we're just going to talk about the computational part. Okay, so let's go ahead and take a look at the first problem. I'm looking at a problem, let's see, problem 5 in your online homework section 9.2. And let's see what we have going on here. We have a pizza place that recently hired additional drivers, and now they believe that the average time for orders is under 44 minutes. They give us a sample of 42 customers that gave the time for deliveries, and they found that the average time was 40.3 minutes. Okay, they also tell us that the standard deviation is 11.2 minutes. We want to complete all of these parts right here. So let's go back to our file, and first I'm going to try to make sense out of this problem. For my null hypothesis, I'm going to say that the mean time for deliveries is 44, okay? And according to the sample mean was 40.3 minutes. So they want to see if 40.3 is significantly lower than 44, okay? So the alternative hypothesis will be mu is less than 44. Notice how the number in each of the hypotheses is the same, okay? So to check if you set it up correctly, think about it this way. Is 40.3 less than 44? The answer is yes. Of course it is smaller, but that's not what the hypothesis testing is going to tell us. It's going to tell us if it's significantly smaller, okay? So let's go ahead and see what else we have. We have the population standard deviation, and we have the sample size, 42, which is big. We can use central limit theorem to solve this problem. Let's go ahead and plug in all the numbers in here. Well, let's see. 0.01 is already in place. For the null hypothesis, I have 44. The sample mean is 40.3. Population standard deviation was 11.2, and the sample size was 42. Okay, so now all of the computations are done for you. We have a left tail. Okay, so for the critical value for the left tail is negative 2.33, and then the p-value would be this value right here. So let's see if we have to answer all of these questions for the online problem. So first of all, it's asking us to do the null and the alternative hypothesis. So the number that's going to go here is 44. It's the same number for both H null and H1. Okay, let's see. What is the alternative? It's less than. That means we're going to say greater than or equal to here. Let's check. This is correct. Okay. Now, just to let you know, if you were to do this on paper and you wrote mu is equal to 44, I would give you full credit. Okay. I think my math lab will actually mark that wrong, but I will give you full credit if you just say equal to 44. That's completely fine. So the z-test statistics, this is the z-score associated with 40.3. Okay, this is how many standard deviation is this number away from 44. Okay, and that is computed right here, negative 2.14. All right, so that's what we're going to plug in here, negative 2.14, 2 decimal places. Yeah, okay with that? The critical scores are, well, in this case we only have one, okay, this one right here, so negative 2.33, right, negative 2.33, okay. If this was a two-tailed test, you would have used plus or minus of this value right here, right, the one I'm highlighting, okay. But because this is a left tail, we're using just one. Let's check. This is good. Okay, so now the question is, what is the conclusion? I'm looking at the z-test statistic and at the z-score, and this value is bigger than this one, right? So in absolute value, it's smaller, but it's actually closer to 0, so it's lying in the non-critical region. So because the test statistic is greater than the critical value, we do not reject the null hypothesis. Okay, which means that 40.3 minutes was not significantly bigger, smaller than 44. Okay, so that's one way to solve this problem using the critical value method. Okay, this value right here, again, if you want to make a normal distribution graph and just put them on the axis, you will see that this one will be closer to 0. It will be in the non-critical region. Okay, so what about p-value? If you were to solve this by p-value, let's see what the p-value is. Here are your p-value. Okay, 0.0161. 3 decimal places, 0.016. Okay, that's good. So how would we come up with the conclusion for this one? 0.016. What is the alpha level? 0.01. We would say what? The p-value is greater than alpha level. We fail to reject the null hypothesis. The conclusion is still the same. We do not reject the null hypothesis. And we would have said there's insufficient evidence to support the claim that the mean time delivered is less than 44 minutes. Okay? Even though it looks like this number is smaller, it's not significantly smaller. All right? So here's your example of a left tail hypothesis testing. Let's go ahead and solve one more problem. Let's do this one right here. Okay, this one is about the average age of customers. Okay, the sporting goods store believes it's less than or equal to 37. They pick a sample of 39 customers and they find out that the average age is 39.3. That's your sample mean. Assume the standard deviation for the customer age is 8 years. Use alpha 0.05 to complete all of these parts. Okay, so let's see. Does the sample provide enough evidence to refute the age claim made by the sporting goods store? Okay, let's see what we're going to do. We're going to say that, what? Okay, so this one would be less than or equal to 37. All right, the alternative hypothesis is the logical opposite, would be greater than 37. Before I do anything, let's just see. 37 and 39.3. Is 39.3 greater than 37? Yes. Okay. The question is it significantly greater? Now we want to do the computation. So again, here we have a rate test. Okay. So let's go ahead and do all of the computations in Excel. We're going to go back here. I'm going to make sense out of it. They want to see if the age is less than, well, they want to see if the actual average age is greater than 37, right? So that's my setup over here. Let's go ahead and delete this. And I'm going to say is 39.3 greater than 37. The answer is yes. Is it significantly greater? We'll find out. So now let's change all of our numbers. So we got 0.05 for the alpha level. The null hypothesis is 37. Sample mean, 39.3. Population standard deviation is 8. Sample size was, let's see, 39. Okay, let's see what we get. All of the numbers are computed for us, so it's up to you which method you're going to use. Well, let's see. The problem, I think, is asking us to do both ways. So the z statistic for this problem is right here, right? 1.795. Two decimal places, 1.795, so that would be 1.8. Okay. The critical z-score. Again, we're using right tail. We're doing right tail test, right? So we only have one. Okay, let's see. That would be this value right here, 1.64. 64. Okay. That's still good. All right. Again, I'm looking at these two. This is the z statistic. That's your critical value that separates your distribution into critical region and non-critical, right? This value right here is smaller than this one. Okay. Actually, wait a minute. This one, 1.64, is the critical value. The z-test statistic is the one that you've computed for 39.3, right? So the z-test statistics is higher than the critical value for the for 0.05, right? So that means what? Okay. The test statistic is greater than the critical value, which is true. 1.8 is greater than 1.64. We reject the null hypothesis. Okay? Because it's further away from the mean by a lot. So, what's the p-value? The p-value then should be less than alpha level. Let's see if it is. Yes, it is. Okay, the p-value is 0.036. Okay? 0.036. That is smaller than 0.05. We reject the null hypothesis. So there is sufficient evidence to claim that the average age of customers at this sporting goods store is greater than 37. Okay? So here you have two examples of one-tailed test. Here's one when you have left tail, another one with right tail. We did both problems with the critical value method and the p-value method, and notice that the conclusion should be the same. So if you guys are given a choice, it is up to you which method you would like, but we should definitely know both methods and how to apply them. All right, in the next video, I will talk about hypothesis testing when sigma, the population standard deviation, is not known, and that will be very similar to what we've done in previous chapter with confidence intervals. Okay, thank you for watching.